Hello everyone! By many requests, I'm making a video about this complicated polar equation example. We are asked to find area, so we will need the formula for the area in polar. And the area is enclosed by this curve in polar coordinates from 0 to pi over 2, and then a straight line connected between its ends. That makes it very complicated, and I will show you in a second why. If I try to plot this function, it actually becomes a beautiful spiral. This spiral that keeps unfolding. When theta is 0, so we were told to look at it from 0 to 1/2. When theta is 0, then it's here at 0 level. If you plug into the equation, r at 0 is just 9 times e to the 0. So it's just 9. So it's over here. This is the point 9, 0. So we're starting here. Then we go to theta 1/2. When theta is 1/2, we are accumulating the lengths over here, right? And then, for example, stop. So r at 1/2 will be 9 e to the 1/2, which is some kind of number, right? It's basically 9 squared of 9. Oh, that's not true. It's multiplied by 0.8. So it's going to be 0.4 because time is 1/2, right? So that is some kind of number. Say it's over here. This is 9 e to the 0.4, 1/2. Theta is 1/2. They're asking to find not the area below it or above it or so on. They want us to connect those endpoints to create a segment and then to find this shaded area. So we're gonna first do this. We're gonna find the area of this whole thing, which I'm gonna put in yellow. This is the area that will be easy to find just using the formula, but that is too much. So then we're gonna subtract from this whole thing a triangle. This is a triangle over here. And we know the area formula for the area of the triangle. So we will do it step by step, don't worry. Step 1, we need to remember formula for the area in polar. That's literally solution. Step 0, I would say. Know the formula. A equals 1/2 integral from alpha to beta r squared d theta. Professionally, we usually write down r of theta squared d theta. That is the formula. You cannot do this problem if you don't know the formula of area in polar. In polar coordinates. So we're going to find the whole thing. We know r. Area is 1/2 integral. The angles are given from 0 to 1/2. Just plug that, alpha and beta. And we have r equals 9 e to the 0.8 theta squared d theta. Okay, that's going to be too much. That's everything in yellow. Remember all of it. But let's find this area first. Let's simplify. It's going to be 1/2 integral from 0 to 1/2. 1/2 is part of the formula, by the way, and that came from the area of the segment. And we approximating everything with segments. 81 e to the 1.6 theta d theta. My cat is hungry, even though I gave him food, which is super not fair. Keep integrating. 81 over 1/2, we can write this down. Integral of e, exponential function. You can do your substitution here. This is u sub. I know shortcut of u sub. Copy this function. Divide by the leading coefficient. That's the shortcut of the u substitution. But you can perform the whole thing and see it will give you the same thing. Bar from 0 to 1/2 equals, finally plug it in. It will be 81 over 2 e to the 1.6 divided by 2 over 1.6 minus e to the 0, which is not 0, by the way. 1.6. E to the 0 is 1. So if we factor out 1.6 in a denominator, multiply by 2, and so on, we will have 405 divided by 16, e raised to the 4/5, or you can keep it as 1.6 over 2. Nobody cares, honestly, too much about this. Minus 1. So that's what I see in my solutions, but you can keep it as 1.6 over 2. Doesn't really matter that much. So 1.6 and 4/5, they claim it's the same thing. So we found the big area. This is the area of the whole thing. How do I know? Remember, we're approximating with segments, everything. So the segments, infinitely many segments, will give me this whole thing, and we don't need it. We need to subtract the extra, and the extra is the area of triangle. It's called A sub t. Step 2, triangle. Area of the triangle is 1/2 base times height. So I'm not sure what to do because where's my base, where's my height? Okay, the base actually is the easy part. I already mentioned at the very beginning. When you plug theta equals 0 over here, it gives you 9 times 1, which is 9. So the base, let's call it B, is 9. Nice. A sub t is 1/2 9 times, and the height of the triangle is this point. How high is this triangle? It is this height, but this height can be determined by this function if we plug the end point, which is 1/2. So the height will be, let's see, like so. H is R, which is 9 times E, 0.8 times 1/2. Let me put it in red. 1/2. You add. Can't. Stop yelling. You're not hungry. You are not hungry. Honestly. Stop it. So, it will be 1/2 the base B and the height. And the height is, and I forgot what was the height. E. So let's see, let's go back. Oh, it's a little bit more complicated than that because of the sine function. That is unexpected. Okay, so I can see in my notes that it is 9 e to the 0.8 over 2. That because we plugged 1/2. Let me just do it. Let me just put it on 1/2 times sine of 1/2. Let me check where did the sine come from. The sine probably comes from the right triangle. So the height and the sine of 1/2. The sine of the angle, that is this one, right? Oh, I see. We're using the sine of the 1/2. Okay, why not? I see. This height, 9e to the 0.8 multiplied by 1/2. That is radius. So it's too big. That is R. That means it's not enough. We need to adjust it to have the height of the triangle. So sine of the angle helps us to adjust it. Interesting. That's a good point. Sine of the angle 1/2 helps us to adjust it. Yeah, I see. This side is sine of the angle. Yes, so let's just agree that the opposite side can be found as sine of the angle of 1/2. Yeah, that makes sense. I just realized that. Why not? Theta is 1/2. So this will be sine of 1/2 times, and then we using this point over here. Because actually the stop yelling, because this actually can be bigger, so we need to adjust it by this function. The last step is to subtract. Step 3. We do the total area, so area minus area triangle. That will be the one we had before. 4 or 5, 16. If you did not simplify that is fine. Nobody really cares about that. Minus 1/2, 9 times 9. 9 is base. The other 9 comes from 9 times e. 0.8 over 2, which is 0.4. Sine of 1/2. And you can see it's approximately 2.05514, like so. That is a weird example, I have to say. Also, this graph is not necessarily looking like this. Depends on the shape of the, so we have this concavity in the spiral, and it's possible that the line is tilted. Then the triangle looks like this. Then the height of the triangle will be this, and so on. So just a little bit too complicated for such a simple practice of the area of the area in polar equations. But good job for trying your best.